Okay, piecewise functions. Piecewise functions, a function defined by multiple subfunctions defined by a specific domain. We're going to take a look at how to graph them here. And again, basically what you want to think of here is you're graphing a piece or a section of an equation. So here's the first equation we're graphing. This would be a quadratic, it's a parabola. We're only graphing a section of it. We're graphing the section that is less than or equal to 1. So I'm going to start with the number 1. You know, one way to do this is to substitute that number into the function and, you know, sort of come up with a table. So if it's less than 1, I'm going to go 1, I'm going to go 0, -1, -2, okay, for x and y. And if I substitute those values into the equation, I would get points to plot. I plot the points. I draw just that section of the graph. The other method here, again, would be to apply your graphing shifts to do this. So a parabola moved to the left 1 and down 2 gives you the vertex, left 1, down 2. All right, and then parabolas always go over 1, up 1, over 2, up 4. Okay, and then right 1, up 1, right 2, up 4. Okay, and that's the x value of 1, so I don't want to go further than that. That's where the graph actually starts. I sketch that curve just to the left of 1. The second section of this function is represented by a linear equation, 3x plus 1. So the y-intercept there would be 1, right, which would be here, but I'm not going to use that point. I'm going to go up 3 over 1. I'm going to use an open circle. Why open circle? Because this just says greater than 1. So that means that point doesn't actually exist. And then if I continue to go up 3 over 1, I'm going to have to add a marker there. Over 1, I'll get the second half of this line, which is linear. Okay. That's you know, sort of the short of graphing a piecewise function. Now I could have used a table here as well, x and y. You know, start at 1, 2, and 3, and get my y values and plot them. So, first example. Here we go, another piecewise function, and another example. Now this one has 3 different lines here, okay? The first line is just 5, okay? Now if that throws you off, it does a lot. Anytime you just have y equals a number, that's a horizontal line. Okay? And we're going to have a horizontal line of 5 everywhere x is less than or equal to -3. So I go over to -3, go up to 5, I have a closed circle, and anywhere x is less than -3, okay, is where that line exists. Then I have a parabola section here from x squared minus 4. So I'm going to go down 4, put my vertex. Remember, parabolas go over 1, up 1, over 2, up 4. Now this one goes over 3, up 9, which happens to be right where that one ended. I'm not going to go over 3 over here because 2 is my upper limit there. So I draw the parabola for that section. And finally, my third section here for this piecewise function is -2x plus 4, only when x is greater than 2. So up 4, 2, 3, 4 would be here, but I'm not actually going to plot that point. Down 2 over 1, not going to plot that point. Down 2 over 1, now I can plot an open circle at 2. From there, down 2 over 1 is the direction my graph's going to go. So here I have a piecewise function made up of 3 sections. Linear, okay, parabola, and decreasing linear. Obviously, any parent families here are fair game. We could have hyperbolas, cubics, you know, exponentials. It's all fair game. And finally, last example here. You know, Word doesn't do the best job at drawing these pictures, so I tried to keep it basic. But we're going to try to write a piecewise function for this function. Typically, in your piecewise functions, we go left to right. So let's just call this h of x. So my farthest left section is a parabola. It's an upside down parabola. We're going to assume it has no stretch factor. That should make it a little bit easier for you. Okay, over 1, down 1, over 2, down 4. We'll be right about there. If I extended that, it'll go through there. So just a parabola. Now, what would the shifts of that parabola be? They would be left 2, down 3. So if I write just the shifts of left 2 and down 3, It's upside down, so it's a negative. And what x values is it true for? Well, it's true when x is less than -2, because that's where that open circle is. All right, the middle section of my piecewise function is a horizontal line. The y value of that horizontal line is 1, and that horizontal line exists between -2 equal to x less than +2. -2 is equal to, +2 is just less than. And finally, my third section of that line starts at 2. It's a linear equation. It's going up 3 over 2. So that'd be my growth, 3 over 2x. My y-intercept, if I went backwards here, down 3 over 2 would be -1. Even though -1 is not on the graph, I still need to include it in the equation. Finally, my domain restriction here is from 2 to infinity. So x has to be greater than or equal to 2. Now, these greater thans and less thans, they do work out specifically, you'll notice here, to keep it a function, right? So this could not be a filled in circle, because then this would not pass a vertical line test. So that's why we have to have this open circle, this closed circle, this open circle, this closed circle, so that it is a function. And that's piecewise functions.